So guys, in the previous lectures, we saw Airflow executors running in a single node system, but we all know that they have their own limitations and cannot be used in real-time production projects where we have huge number of data pipelines with growing complexities. So one node won't be sufficient to handle those many DAGs, and you definitely would have to think of scaling up your Airflow environment to a flexible and scalable architecture, that is to the multi-node cluster architecture. In multi-node cluster, the workload can be distributed amongst multiple workers on different machines. And to run Airflow on a distributed cluster system, it has to be configured with Celery executors. So welcome to this lecture where we will see what is a Celery executor and how to use it with distributed multi-node cluster setup. But first of all, let me shout out some formal points on it. Celery executor is one of the best ways you can scale out the number of workers. Yes, we know it. It makes it easy to scale out workers horizontally when you need to execute lots of tasks in parallel. Using Celery executor, you can distribute task loads amongst different multiple worker machines to take task parallelism to another level. Celery is an asynchronous task queue based on distributed message passing, and for that at the backend it uses a message queuing framework such as RabbitMQ or Redis to manage communication between multiple task services. Same like local executor, Celery also requires a backend database to store your task results. Databases like MySQL or Postgres. Alright, most of the things we already knew. Let's now load our Airflow with Celery executor. To work with Celery executors, you need to define a separate compose file with its exclusive derivatives. But you don't have to worry about it as Puckle has already written it. We can directly use this Docker compose file to set up our Airflow with requisite Celery services. Guys, this compose file is similar to that for local executor, but to run the Celery, there are some additions done. So starting with, we have the messaging queuing service. Puckle has used Redis, but you can use RabbitMQ too. Database is same Postgres, and executor will be Celery. You can change this property in Airflow's configuration file as well. Then we have an important property for netkey. Guys, by default, Airflow saves the passwords for connection in a plain text within the metadata database. But we can install and use a crypto package to encrypt the data with this fornet key. Fornet guarantees that a message encrypted using it cannot be manipulated or read without the key. Any encrypted message will require this fornet key to decrypt that message. Then folders are mounted in the same way. And yeah, next we have Flower service. Guys, Flower is a web-based tool for monitoring Celery workers and task progress. So Flower service being installed, you will be able to see the task executions in a separate Flower UI, other than the Airflow's UI. And you can access the Flower UI at port 5555. Scrolling down. Now, as we know from the multi-node Airflow architecture, in these setups, scheduler and worker run as a separate instance. So we have separate derivatives for those services as well. This is for scheduler and this is for worker. The properties in both of them you would see is same as of any other service. Okay, so that's how the compose file for Celery executor looks like. Now let's load the Airflow instance with this compose file. In the PowerShell, run docker compose. Notice that we are running Celery executor compose file. This time it is pulling a Redis image from Docker Hub. Let us wait for some time to have it download. Done. If I list the running containers, see, this time we are running Airflow in distributed mode with Celery executor. We have a separate running container for each Airflow service. Like this is for worker and this is for scheduler, so on. So let's go to the browser and run our favorite tutorial DAG. Again, please notice that I have removed any operator relationships from the DAG. Enable it and trigger. Yes, it is running. Great, it has successfully completed. Go to the Gantt view. You can see that with Celery Executor, the tasks have done a parallel execution. Now for Celery to monitor the workers and task progress, we have Flower service installed. So let's have a quick look on that too. To access, go to localhost, port was 5555. This is how it looks. On the dashboard, we have worker name, its status, then active, then we have some columns related to task statuses. This online status specifies the worker node is healthy. Then this active column shows you the real-time data about number of active tasks currently being executing. Processed, the number of tasks that are carried out till now, the number of failed tasks, succeeded and retried. And as currently we have only one node in my system, so that's why only one row is there. If you would have used an actual cluster with n number of nodes, then there will be each row for a worker in the cluster. Anyways, let's run the tutorial DAG one more time. Flower UI will give you the real-time data about tasks without any need to refresh the page. See, currently 3 are active. Now 5 got succeeded. 1 is pending. Yeah, all got succeeded. Going to this task section, it will give you more details about the task, like when the task was received, at what time it was started to execute, then time took for its completion, worker node that has carried out that task, and all these things. One thing I would like to add here is, if I go to airflow.cfg file, under the Celery configurations, we have a property called worker concurrency. Worker concurrency determines how many tasks a single worker can process. By default, it is set to 16, means a single worker node can have 16 tasks at once. You can tweak with this number as per your needs. But please be careful. In case if you increase the worker concurrency, then you have to make sure that your worker node has enough resources to handle that load. Otherwise, it may go down. And with this, I would say that's all for the Celery Executor.